Hello, welcome to R5 Polynomials. Let's get started. The product of a number and one or more variables raised to powers is a term. We see right here, 3x squared y is a term. It's the product of a number and one or more variables. The number at the beginning of the term is the coefficient of the variable. So in this case, our term, which was 3x squared y, has a coefficient of 3. It's the number at the beginning of the term. Next, we have a polynomial. Is a term or a finite sum of terms with only whole number exponents on the variables. A trinomial, binomial, and monomial are names of polynomials, poly meaning many, with a specific number of terms. So we could say a trinomial has 3 terms, a binomial has 2 terms, and a monomial has 1 term. The degree of a term is the sum of the exponents on the variables. So here we have a term, and it only has one variable, and its exponent is 3. So this is a term with a degree of 3. Here we have another term. It has a variable with an exponent of 3 and another variable with an exponent of 1. So this term has a degree of 4, because remember, we're having to sum the exponents on the variables. Next, we could look at the degree of a polynomial. So notice the difference. We can talk about the degree of a specific term or the degree of the whole polynomial, which would be the greatest degree of all its terms. So here I've given you a polynomial, 1, 2, 3, 4. It has 4 terms. And if I want to know the degree of the polynomial, you have to find the term with the largest degree. So this term has a degree of 3. This term has a degree of 4. This one has a degree of 2, and this one has a degree of 0. So we would say this is a polynomial with degree 4. All right. Example 1, identify each as a polynomial or not a polynomial. Then, if it is a polynomial, tell me the degree, and is it a monomial, binomial, trinomial, or none of these? So the first one, I'm taking a look to decide first, is it a polynomial or not? And that takes us back up to here. A polynomial is a term or an infinite sum of terms with only whole number exponents on the variables. So I'm looking at the exponents that are found on these variables. They're all whole numbers. And so, yes, this is a polynomial. Specifically, what kind? Well, I see 3 terms, so it's a trinomial. And it wanted to know the degree of the polynomial, so I'm looking at the degree of each term. And the largest term has a degree of 7. So it's a trinomial with degree 7. The next one, I'm looking, and notice this. We've talked about this in a previous lesson, right? This can be rewritten as t to the negative 2. And negative 2 is not a whole number. So this does not fit the definition of a polynomial. We're going to say not a poly. The reason is because that exponent it's an integer, but it's not a whole number. Okay, and the third one, let's see. This fits the definition because all of my exponents are whole numbers. So we're going to say, yes, it's a polynomial. And there's only one term, so it's called a monomial. And finally, what's the degree of this monomial? Well, I have a 3 plus a 2, so it's a degree of 5. Go ahead, pause the video to try the next 3. All right, so now you're checking how you did with these 3 answers. Pause again as you need to revise and make note of questions that you have to ask in class. Okay, example 2, adding and subtracting polynomials. Addition's pretty straightforward because you're just going to essentially drop your parentheses because you're distributing this and it's not going to change any of your signs. So I'm just going to ignore my parentheses. And I'm going to look for like terms that I can add together. So this is a 8m to the 4 p to the 5th and 11m to the 4 p to the 5th. So I can add those together to get 19m to the 4 p to the 5th. Remember, it's like saying 1x plus 2x equals 3x. Let's write that there. 1x plus 2x, we know it gives us 3x. So that x is just tagging along. It's only the coefficients that are adding together. And then let's see, this second term has a m cubed p to the 5th, and so does this one. So I know that these can combine together. A -9 plus a 15 is going to give me a 6. So plus 6m cubed p to the 5th. All right, this next one, okay, a little more work going on here because I'm going to need to distribute that 4 and the 5, or I could say I'm going to distribute the -5. So let's write out some more here. We're going to have 4x squared minus 12x plus 28 minus 10x squared plus, remember, negative times a negative gives us that positive, 40x plus 20. Now I'm going to pause and see what are like terms that I can combine. So I'm going to end up with -6x squared. And these right here are going to give me what? Positive 28x. And then finally, just my constants are going to give me a plus 48. All right, so now you are going to pause to try the next two. Okay, so take a look at those two answers to see how you did. Again, pause as needed. Remember, we want to get in the habit of writing our polynomials with the terms in order of descending degree. So that's just like kind of standard in the math world. Just have things a little bit organized, make me happier. Okay. Example 3, multiplying polynomials. So I'll do the top, you'll do the bottom. Let's take a look. With this, I literally just like to keep things organized. So I'm going to take my 3p squared and multiply it by p cubed. This takes us back to our exponent rules. We're multiplying the like bases, p in this case, so we're going to add those exponents. Okay, so it's going to give us 3p to the 5th. Then the second part is going to be the 3 times 2. And then I'm going to have p to the 1st times p. So I'm adding those exponents to get p cubed. And then to the third term here, I'm going to end up with a -24p squared. Now I am going to change my color just to kind of help us see what's going on. For this one, I'm going to do my -4. And I'm going to pick up the pace a little bit because we're just using the same properties again and again. Plus 32p. Make sure I'm on the right track here. Yep. And then we need our new color. Sure, no, green. Okay, there we go. And oh, this is 1, so that's going to be super quick. Things are just going to stay how they were. Okay, now we're going to look to combine like terms. So do I have any other p to the 5th? No. Then I'm going to look for p. I'm going to cross it out, so I already used it. Here I have a p to the 4th. And now I have plus 6p cubed plus 1 more p cubed. So that's going to be 7p cubed. All right, -24 and a -8 is going to give me -32. Okay. I'm talking and doing math and scanning to make sure there's no other terms that combine with it. So now we're going to get our 34p and our -8. Let's see, how did I do there? All right, I think we're good to go. So now it's your turn to show me what you can do. Okay, checking that answer. You didn't have quite as extensive. Notice that when I did it, we had a trinomial times a trinomial, and you only had a binomial times a trinomial. So you had fewer terms to work with. You're welcome. Okay, example 4, multiplying two binomials. Remember, we come from a varied, amount of background. So whatever method you have that works for you, do that. Okay, I kind of stick with that FOIL method, but if you've heard of box or area method, do what works for you. As long as it's mathematically sound, go for it. So here we have, 24m squared minus 18m plus 4m minus 3 gives us 24m squared minus 14m minus 3. Okay. For this next one, I'm going to just let that r squared hang out in front, and I'm going to first deal with this. That's going to give me 9r squared. Let's take a look what happens here. Minus 6r plus 6r minus 4. Okay, so this right here is going to sum to 0, right? And what was my clue that I knew that was going to happen already? Take a look at what these binomials look like. Okay, they're exactly the same with just the sign is different. And so whenever that's the case, 3r plus 2 times 3r minus 2, it's always going to have the middle term sum to 0. So if you just get used to recognizing that, it can save you some time. All right, and then now I'm going to distribute my r squared to what remains to get my final answer. All right, pause and see what you can do. Checking those two answers. And that brings us into kind of what I hinted to already, because again, this is supposed to be a review, right? Difference of squares. Okay, that's what we were looking at before when you have the same binomial, just different with a sign. Anytime you have something that looks like that, it's going to factor into, in this case, x squared minus 9. So here we broke it down just using generic variables, and then I gave you a specific example. Okay, notice that if you take the x and you square it, you take the y and you square it, these two signs are opposite, and here it's a difference. It's called a difference of squares. Notice difference meaning subtraction, squares because these are both perfect squares. This is a perfect square, x times x. This is a perfect square, 3 times 3. All right, then something else we want to recognize is perfect square trinomials. So anytime we have the same quantity that's being squared by itself, then it's always going to follow this pattern right here. And I don't want you to get tripped up. I was just trying to save some space with this. So you could have a case where it's x plus y, and then your signs would be a plus and a plus. If you have a case where it's x minus y, then you would have a x squared minus 2xy plus y squared. So whatever sign's on top corresponds all the way through, and then the bottom goes with each other. Okay, so here in this case, following this pattern, it says you take this value and you square it. So I have a x, I'm going to square it. Then it says your middle term is composed of 2 times x times y, or in our case, 2 times x times y. And then your last term is just your y squared, so 5 squared. So really what I would write is x squared plus 10x plus 25. Okay, let's see. So Here, what I recognize is that I have the same exact quantities, just different in their sign. So I know I can take the first one and square it. If I square it, and then I'm going to have a difference, and I can take the second value and I can square it. So this is going to give me a difference of squares. Now let's actually square it. So it would say 25m. When you have a power raised to a power, you multiply, minus 9. That is a 6. Okay, there we go. And then this one over here, if it helps you to expand it out, you can do that, because what that means is you have that quantity times itself. And so you can do your little swooshies and multiply, or you can just recognize that, hey, this is going to be a perfect square trinomial. And for a perfect square trinomial, it follows the pattern of x squared plus 2xy plus y squared. I put my plus in there because I see my problem has a plus. So I'm going to take the 2m and square it, plus 2 times 2m times 5 plus 5 square it. Now I'm going to actually simplify that down. So 4m squared plus 20m plus 25. Okay, see what you can do. And checking those two answers. Remember, factoring, well, we're not multiplying, factoring, working back and forth. It's gonna get better with experience. Okay, so the more you do it, and it's been a minute since you've done it, it'll come back easier. Let's see. Okay, while 3x quantity squared is the same as 3 squared times x squared, which is 9x squared, this is not a thing. Okay, see the big not equal to. We cannot just simply take this 2 and distribute it here, because our things, our variable and our constant are being separated by an operation of addition or subtraction. So this is something that kids think they can do. They try to do it, and no. I say bad things happen in the universe when you do that. So don't forget that, just like we've seen above, there will be a middle term. Okay, so let's see. Multiplying more complicated binomials. Oh, okay, so this I put optional. I am just going to ask you if you want to try these, pause it, and then I'll show you the answer. But I'm not going to go through it. This is not something that I'll include on an assessment, okay? So again, optional. This is, we'll talk about something later in the year that'll help you with that, but not something we need to stress about right now, okay? And finally, dividing a polynomial. So the first part we're going to do is dividing a polynomial by a monomial, and that's simply just using your exponent rules, okay? So what I want you to do is think about it. 16a to the 5th minus 12a to the 4th plus 8a squared. You are dividing by 4a cubed. So this 4a cubed is dividing all of these three terms. So if it helps you to think about, sometimes I draw this. First, we have to do this division problem. That's going to be 16 divided by 4. And if I have a to the 5 over a to the 3, I'm left with a squared in the numerator. Okay, then I need to, I don't know, use this color and divide this term. So I have a negative 12 divided by 4 gives me negative 3a, because I had 4 there and 3 there. Okay, and finally, I have to divide this term. So that's going to give me a positive 2. Notice when I'm circling, I'm including the sign in front of the coefficient, right? And oh, this one I only have 2 a's, and then I have 3 a's on the bottom. So that's going to mean that I have 1 a left over, and it's in the denominator. All right, so that's what that looks like. Love it. So Let's try this one. Let's see what's going on here. Negative 180 x to the 4th y to the 10th. 90x y to the 4th minus 100y dividing by negative 30x squared y squared. So same process where each of these three terms is being divided by this one in the denominator. So I'm going to take it one by one. Negative divided by negative gives me a positive, and 180 divided by 3 is going to give me 6. Looking at my variables for x and y. Remember, when we're dividing, our exponents will subtract, okay? Next, I'm going to have a negative 3. I'll have 1x left over in the denominator and 2 y's on top. And finally, negative divided by negative will give me a positive. 100 divided by 30, the best I can do there is 10 over 3. I have no x's to simplify, so those two just stay in the bottom. And I'm left with 1 y on the bottom. All right, it is your turn. All right, checking those two. And here we are, finally. All right, examples 9 and 10, dividing polynomials. This is one way that we can divide polynomials. We'll look at another way later on in the year. But things to remember, we're going to follow the same steps as if you were dividing just normal numbers, right? Instead of polynomials. We'll go over that in a second. Both polynomials must be written in descending order. And always check for missing terms. You need to insert a term with a 0 coefficient in its place. Lastly, remember to add the remainder over divisor to the end of your quotient. So let's just review real fast. If I were to ask you to divide 1,246 by 5, and you're like, well, that's a big 4-digit number, and we just take it piece by piece. So what about, can you do 12 divided by 5? Well, sure. You can say that 5 goes into 12 2 times, and that gives you a value of 10, and you subtract, and you're left with 2. And then now you can bring down your 4. And then you can say, okay, well, I know 5 goes into 24 4 times, because 4 times 5 gives me 20. And then we're subtracting, and we're bringing down. And then lastly, you can say, I know that 5 goes into 46 9 times, because 9 times 5 gives me 45, and I subtract, and I'm left with a remainder of 1, my quotient 249 with the remainder of 1. Okay, we're going to do that same process down here. Okay, so first off, I am going to write it the same as I did that one there. As I'm writing, I'm looking at my terms to see if anything is skipped over. What do I mean by that? This is m to the first power, and this is m to the 0 power. So everything starts at 1 and we go down, we're good. This starts at m to the third, m to the second, m to the first, m to the 0. So we're great. We have no skip terms. Okay, first thing we want to do is ask ourselves, remember, coming back up to here, we always wanted to be able to like move on down the line and get rid of whatever was right here in the beginning. In this case, we were trying to get rid of 12, then we were trying to get rid of 24, then we were trying to get rid of 46. So here we're trying to get rid of this 4m cubed. Right now I have 2m. Just focus on this right here. So I can say to myself, how close can I get to this? Or can I get exactly this? 2m times what gives me 4m cubed? 2m times 2m squared. And I'm going to write that up top, because if I do 2m squared times 2m, I'm going to end up with 4m cubed. Oh, but don't forget, we also have to multiply it by this -1. So 2m squared times -1 is 2m squared. Notice where I wrote it. It's lined up in this column. Everything in this column is going to have m to the third power. And this is my column for m squared. Now that I've done that, I'm going to subtract. Let's do red for that. So we're going to subtract. And this subtraction sign is going to be for the whole thing. It's going to read 4m cubed minus 4m cubed. Guess what? 0. That's perfect. That's what I wanted. Now the next thing says negative 8m squared minus a negative. Minus a negative is plus. So really it's like saying negative 8 plus 2. And then I can bring down what remains. All right, we're going to do that same process again. So right now I have 2m. What do I need to multiply it by so that it becomes a negative 6m squared? Yes, negative 3m. Negative 3m times 2m gives me negative 6m squared. And then I do my negative 3m times negative 1. Negative times negative is a positive. All right, now we will subtract. Let's do this color. Subtraction, and this is going to go for both pieces, okay? Negative 6 minus a negative. Well, that's like plus. Negative 6 plus 6, gone. It should be gone, or else we didn't do something right. Next part. 5 minus 3. 5 minus 3 gives us 2. And bring down our 6. Okay, let's do the process again. So let's see. We'll go back to this purple color. I have 2m. What do I need to multiply it by to have 2m? Just a positive 1. Notice how everything's lining up, right? 1 is a constant, and it's in the column of my constants. This is how your work needs to be organized so it all lines up. So let's do this. 1 times 2m and 1 times negative 1. Now we're going to subtract. 2m minus 2m. 6 minus a negative 1 gives us 7. So how do we write our final answer? Because we can't go any further. I can't say to myself 2m times something to get 7, because notice that this is of a higher degree, 2m, than 7 is. So I know I'm done. My answer is written as 2m squared minus 3m plus 1 plus 7 over 2m minus 1. I put at the top, remember, to add the remainder over divisor. Add the remainder over divisor at the end of your quotient, because this 7 still has yet to be divided by 2m minus 1. So it is still going to have the divisor underneath it. Okay? Let's do that process one more time together. Notice this time we're asked to divide by x squared minus 4. And this has a degree of 2, but then there's no piece that's a degree 1. So I'm going to add in a placeholder, if you will, or the linear part of the polynomial that has a coefficient of 0. So I'm not changing the problem because it has a value of 0. I'm just going to put that there to help things be organized. 3x cubed minus 2x squared. Then look, I'm going from a degree 3 to a degree 2. Now I'm missing a degree of 1. So I'm going to put 0x, then my minus 50, which is of degree 0. Okay, let's see. I'm going to try to stick with the same colors. So remember, your goal is to create 3x cubed. You have x squared. So x squared times what gives you 3x cubed? 3x. And that goes here. Notice where I put it. I put it above the x column. So 3x times 3x squared, 3x times x squared gives me 3x cubed. Don't forget I have to do that 3x times 0x, which is going to give me 0x squared. And 3x times negative 4 is going to give me negative 12x. Everything's lining up. Okay, this subtraction, 3 minus 3, negative 2 minus 0, 0 minus a negative 12, and bring down. All right, next, x squared times what gives me negative 2x squared? Negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times 0x is 0x. Negative 2 times negative 4 is a positive 8. Now we're ready to subtract. Negative 2 minus a negative 2, 12 minus 0, negative 150 minus 8. All right, now remember what I said. The degree here is less than the degree here. So I know I'm done. I cannot go any further. Because what you would be asking yourself is x squared times what gives you 12x? That doesn't make sense, right? Plus another sign, I'm out of columns. I've already filled in my constant column. I can't keep going. So I know I'm done with the problem here. So writing my answer, I take from the top to get the quotient 3x minus 2. This represents my remainder. And so I'm going to say plus. This goes in the numerator over x squared minus 4. There we go. All right, your turn. And checking those final two answers. Bring your questions to class, come see me, and get the help that you need. All right, guys? Thank you.